Good morning, guys, and welcome back to the last solving session on chapter 17, where I chose a very important problem. Why am I saying that this is a very important problem? Because in this problem, we're going to see that we will use all the knowledge required in this course. All right. So if you remember, guys, whenever I had a pulley and or a dependent motion for particles, the first step ever was to put the equation of displacement, the relation between S1 and S2 after, of course, specifying the datum, and then start solving. Now here, the difference between such problem and the problem of particles was that here I have a rigid body on one side, and this is the disk. How can I know that here I have a rigid body which is not, which could not be considered as a particle? Because as you see, guys, they are giving me first the radius, they are giving me also the mass, and they are saying that this disk roll without slipping. So which means, guys, this disk could not be assumed as a particle. It has a dimension. Its radius is 0.2. It could not be neglected compared to other sizes. Now here for B, since I don't have any dimensions, I'm considering B like a particle, and this particle has a mass of 10 kilograms. So right here, guys, I have a rigid body, which is this disk that has dimensions that could not be neglected, and I have a particle here. Now, does the dependent motion differ between rigid body and particles? No, in fact, I can also apply the equation for dependent motions here, the equations of displacement, velocity, and acceleration. But these equations will be considered additional equation to this rigid body, to the sum of moment, sum of x, and sum of y, in order to know my unknowns. Guys, if you go back in this chapter, you can see, guys, that we have developed three main equations to use for rigid body. These equations are sum of fx is equal to magx, sum of fy is equal to magy, and the sum of moment around g, the center of mass, is equal to ig times alpha, and these equations are applied for any type of motion, especially for the general plane motion, all right? So where I have translation and rotation. If I take a look on this disk has both translation and rotation, and in fact, this disk in the question is rolling without slipping. So I have an additional information that this disk is also rolling without slipping. Which means, guys, let's go back to the slides where I have no slipping condition. If I don't have a slipping condition, if there is no slipping condition, the additional equation will be AG is equal to alpha R. And what is the direction of this AG? It is to the right if the disk is rolling in clockwise direction. All right? So, guys, I have here a lot of equations. I'm going to repeat them. The first three equations are these three equations that are applied for general plane motion. Sum of x is equal to magx, sum of fy is equal to magy, and sum of the moment around g is equal to ig alpha. Now, remember that this equation could be also replaced by the sum of moment around any point is equal to ig alpha plus the moment of magx and magy that are the resultant forces on x and y. So I have these three equations, and since I have no slipping condition, I can add this equation AG is equal to alpha R. You cannot use FF is equal to mu static times M, because you have to verify this assumption if it is correct by checking if FF is less than or equal to mu S times N. So you're gonna do this at the end of this problem to make sure that yes, this is the case of no slipping condition, even if the question is stating this clearly, all right? So guys, right now I have four equations, sum of fx, sum of fy, sum of moment, and ag is equal to alpha r. So I can solve for only four unknowns. However, guys, since here I have a dependent motion, so in example 12 I have a dependent motion, so I can also add the equation for acceleration. I can put a datum and add the equation of acceleration. But if you remember, guys, this equation of acceleration will include A of this disk as well as A of this particle here at B. So I'm adding an additional unknown, which is the acceleration of this P. What should I do? I have also to add the equation of acceleration by taking this body as a free body diagram. So guys, there is a lot of equations here. I have to specify what are my unknowns, and then I have to add the equations so that I have a system of simultaneous equations where the number of equations is equal to the number of unknowns. So let's start. Okay, guys. The first equation that I'm gonna write is sum of fx is equal to magx. And here, of course, I mean by this agx of this disk. All right? So, and if I take a look here, guys, on this disk, what is the rotational direction of this disk, how it can move? I know, guys, that since this mass here is vertical and since this mass here is horizontal, so there is a gravity here. This means, guys, that if this B is moving downward, then this disk will move in this direction. Now, guys, if I indicate my alpha in this direction, then as I saw here in this figure for no slipping condition, if this is the direction of alpha, then AG will be in this direction, all right? So I'm gonna put this as AGX, of course. So this will be AGX. And guys, please, guys, focus on the directions because you're going to see that for dependent motion, the acceleration from the datum will be opposite to this AGX, so there will be a minus sign. Please focus on the directions, all right? So I'm saying that if this is the rotational angular acceleration of this disk, then this will be AGX, all right? Now, guys, what are the forces in x direction? So let's show the free body diagram of this disk, and remember it is a rigid body. What's the difference between a particle and rigid body? The size could not be neglected, which means, guys, I cannot put all the forces on the center of mass as I always do for the particle. So here, for a rigid body, the forces are not all applied on the center of mass, and that's why I'm gonna have a moment of force. Alright? So guys, basically, what are the forces exerted on this disk? I have the weight. Of course, the weight should be on the center of mass. I have the normal, and don't forget that for a rigid body, the normal is perpendicular to the contact surfaces. So here, the contact surface is on this point, which means N will be here. All right, so this will be N at this point right here, okay? Now, what are other forces? I have the tension, and since the rope is from the center of mass, then here the tension will be from the center of mass. But if the rope, guys, was here on this point, then the tension will be from this point right here. And then, what about the friction? The friction will be on the contact surfaces. So I'm gonna say that this will be my friction. Alright? So what are the forces in x direction? In fact, in x direction, I have minus FF, alright, plus T is equal to MAGX. Okay, guys? The normal and the weight are in vertical directions. Now, what about sum of Fy, which is the second equation for general plane motion of a rigid body? Sum of Fy is equal to MAGY. Alright? So if I state all the forces in y direction, I'm gonna have n minus the weight. What about AGY? Guys, if you go back, since this disk is rolling without slipping, then I did the proof, guys, in chapter 16, I think, in kinematics of rigid body. So we proved, guys, that in this case, the center of mass will have only AGX, all right? And this AGX will be equal to alpha times R, which means, guys, AGY is equal to 0. So from the second equation, n is equal to weight, all right? Now, I can remove the second equation. So I can remove this equation, guys, so that because I know that n is equal to the weight, and then n will not be my unknown, all right? So I can get rid from this equation, putting on my mind, guys, that the normal force is equal to the weight, which means the normal force is no longer an unknown, all right? And you can keep it and count it. It's up to you. Now, what about the third equation? The third equation is the sum of moment around G. So the sum of moment around G is equal to IG alpha. All right? Which means what, guys? What are the forces that can do a moment around a G? These are the forces that are not passing through G. I know that the weight is passing through G, and here the normal force, if I extend it, because since this is the contact, guys, it is on the vertical line from G, then the normal force will pass through G. This doesn't mean that the normal force is applied on G. No, it's applied on the contact surface, which is here particularly if extended, can pass it through G. All right. So N has a zero moment. The only force that has T is also passing through the center of mass because the rope is passing through the center of mass. Then T has also a moment of zero. I'm gonna only have the friction force, and this friction force here is doing the same rotation in the same direction of alpha, which means it's F times R is equal to I G alpha. Now what is Ig? Since this is a disk, it's half m r squared, and of course this r is this radius 0.2, so it's null. All right, times alpha. So this is Ig times alpha. Now let's, guys, let's underline all the forces that are unknown, or all the parameters that are unknown in blue. I don't know FF, I don't know T, I don't know AGX, right? And this is also, you can count N as your unknown, and then you can count this as an equation. So you can do this, right? So let's put a line under N, or you can remove this equation knowing that the normal is equal to the weight, and I don't know alpha, right? And don't forget, guys, since this disk is rolling without slipping, then I can add the fourth equation, as we said in the slides, that states that AGX is equal to what? It is equal to alpha times R only, right? So how many unknowns do I have in this system right here? Let's count them. Okay. FF, T, AGX, N. So as I said, guys, if you count N, you have to count this equation. If you get rid from this equation, you can remove N. It's the same. All right? Alpha. And now, how many equations do I have? So I have 5 unknowns with 1, 2, 3, 4 equations. So I need to add an equation in order to solve for these unknowns. How to add this equation? What I should use? I should use, guys, the equations for dependent motion. However, guys, I have to pay attention to the directions.